welcome everybody. This is Laura Portalupi. I am a community manager here at Coursera, and this is the How to Become a Site Reliability Engineer and Why You Should webinar. And we are really happy to have you here today to hear from our presenter, Henri Devieux. Henri is a site reliability engineer at Dropbox. He studied computer engineering at the University of Delaware and worked several years as a Unix systems engineer, then as a software engineer, primarily using C, Python, and Go. He's passionate about complex distributed systems and understanding their most intricate details. So without further ado, I will pass this over to Henri and enjoy the presentation.
Thanks, Laura. So I'm Henri, and I work at Dropbox as a site reliability engineer. And so in this presentation, I'll kind of give a little bit of a background about myself, how I got into this career, and some information about what SRE is and how it's valuable to an organization, and also some of the technologies and tools that I use that other SREs use on a day-to-day basis. And then kind of for the people who are interested in this line of work, maybe some classes and recommendations and things to get started that might help, somebody take the path to get into this career. I really enjoy this work, and it's kind of a perfect career for me because I'm passionate about it, and I show up and get to solve the problems that are exciting to me every day. So I would love to share that with other people and get more people involved in becoming an SRE and learning more about it in general. Not only is it interesting for people, and I would like to have other people find this career that they enjoy, but it's also really valuable to organizations. And so many tech companies in the Bay Area are looking to expand their SRE organizations and hire more of these roles because of how valuable it is. So that's another aspect to it, is that it's really important and necessary and growing because of that. So there's many reasons that this is a pretty good career, and it's exciting. So let's get started. So I guess we should start by kind of defining what is site reliability engineering. And so to do that, I'll give a little bit of a background. And kind of historically, there's been two separate organizations within an engineering company. There was operations and there was software engineering. So operations is the systems administrators, the network engineers, the IT support folks in the data center who will replace a hard drive and a server if it's failed. The Linux systems administrators are the people who, they would get an alert and say, memory is too high on this one server, you might need to go and debug the problem. So they were in operations roles, which is pretty, here's a problem, they go fix it. And then there's software engineering, which were the programmers that built the product. And so the software engineers were tasked just with writing code that built the thing that they were working on. And that thing could have been a database. It could have been the back end to a website. Let's say it was an e-commerce company. They could be building any one of those products. So these were the two aspects that made the technology work, and they go hand in hand. But there was no middle ground between these two separate entities, and it did create some problems with this approach. So the number one problem is that the number of operations engineers that a company would hire has to scale linearly with the size of the infrastructure, and that can get pretty expensive. So what I mean by that is, if you have 2 data centers and 50,000 servers, you need a pretty big operations department to manage all of that, to fix all of the problems that happen on all the servers. There's dozens of applications running on all of them that have bugs that need to be diagnosed, and a lot of troubleshooting. And so the bigger that infrastructure gets, the more people you need to operate it. Where writing the software that runs on all of that might not need more people in the linear way that operations would. So that's kind of the first thing, is that line item that in the budget of how many engineers are required to operate the technology gets pretty expensive for companies. The other is that a lot of the software engineers didn't have expertise to write operations level software. And that's because they were pretty removed from operations work itself. Most software engineers historically weren't logging into the Linux server and seeing what was wrong, or troubleshooting a network issue. They were just writing the code for the thing that they were working on. So there was no software engineers that were like automating a lot of these tasks and programming things for the operations engineers. Another issue with that approach was that it made software product development move pretty slowly. So the software engineers were also responsible for the testing of their code, for rolling out new changes, and that can be a pretty slow problem. If you're worried that you're going to introduce a bug, you're going to do a lot of prep work to try to find everything yourself and diagnose issues before you start rolling out new code into the production servers. And lastly, there was no one really responsible for automating a lot of that operations work. And by automating, I mean, if you could write some code that saved a lot of the work hours from those operations people, that would be really useful to the company, but no one was really tasked with doing that. Certainly if you're in the operations department, that's your job. So it's not usually in your interest to automate some things. And also it's sometimes the skills aren't there and you're not incentivized to do that work. So there was a few approaches with that to operations versus software engineering method, and they were kind of in conflict with one another. So that's where SRE entered into the picture. So this is a quote from Ben Traynor. He's usually one of the people as viewed as creating SRE. And he's quoted as saying, well, it's what happens when a software engineer gets tasked with what used to be called operations. And so this whole idea of SRE and automating and software in the operations space came about somewhere around 2003, primarily out of Google. And one of the leaders of that was this person, Ben. So the idea was that it was going to solve a lot of these issues that I had talked about and make a little bit more of an intelligent approach to how a software product is managed, how it's understood, how changes are deployed, how it's administrated, how problems are fixed. It was a more modern way of doing that whole world. And it was called site reliability engineering. And so it's about a 15-year-old term and an organization. And it's had a lot of evolution since then. Now it's in a lot more places than just Google. So, with that little bit of a background, it's, where could you get a job as an SRE? Well, almost all the software technology companies out there have some form of SRE. Google, Facebook calls it production engineering, Uber, Apple, you name it. These companies have this SRE organization. Some call it different names and some approach it differently than others. Every company is going to have their own unique take on how it works. Primarily how the SRE organization interacts with their software engineers. So it's out there in most of the tech companies, but it's also expanding into many non-technology companies. A lot of companies are now viewing it as an evolution of their traditional operations roles. One example is Target. Target has a large technology infrastructure. They have a website. They have all sorts of code that needs to get run and operated. And so they had traditionally a lot of operations folks, and they're now building out this SRE role to, again, be a little bit more modern with their approach to how their technology is managed. The other thing that I'll note is that I like to say it's backwards compatible. The skills that an SRE would have is they're always like an addition to a lot of the skills that a traditional IT role would have. So if you were a data center technology operator, where you're managing servers and replacing hard drives, SRE's skills are built on top of that. So it's adding things to a lot of the traditional roles: network engineer, Linux systems administrator, database administrator. A lot of those roles, you add to them and you can get SRE. So it's always beneficial to learn and take classes and get involved in a lot of what's happening in the SRE universe, because it only helps and it can add to any role that you would have done in the past in traditional IT. So it's a pretty powerful field, and all the skills are very useful. So, oops, here we go. So with all of that in mind, is SRE for everybody? No, it's not. So I put together just some things here to get a feel for some of the things that you might need to know before deciding if SRE is the right career for you. The one, this is kind of a joke, but are you comfortable working at a computer almost all day? I love computers, and so it's important to know that the job of an SRE is sitting at a computer and working at a terminal, troubleshooting problems, looking at graphs, writing code, interacting with other engineers also, but a lot of it is just you at your computer doing the work that you need to do. The second one, I think, is the most important to point out, and that's, do you enjoy solving a challenging puzzle that can take days to figure out? So a lot of the things that an SRE would do is diagnose some intricate bug that's happening in a software stack. So say it's a database that has all of your users and you're some company. That database might have some weird problem that users are experiencing when they're using the website periodically, and it's very vague how it's happening. And you might have to dig in and really spend a lot of time figuring out what is going on. And that could be a puzzle. It can be very challenging. It can take a lot of time. It can take a lot of different tools and angles and approaches. And the type of person that would make a good SRE is the type of person who would enjoy that work, who is excited to dig into something and really figure it out. So that's kind of one of the most important skills in this career. And the third, which is also very important, is that you have to be okay working under pressure when something critical is broken and you're the on-call engineer. So almost all SRE organizations have on-call, and that's the person who's going to get a page if something's not working. That thing not working could be really, really important. If you're at a company like Google or Facebook and the site is down, like YouTube went down a few weeks ago, it was down for several hours. There was some SREs getting paged, waking up in the middle of the night, figuring that problem out. And if YouTube is down, there's a lot of pressure. So you have to be okay working with that pressure and kind of waking up in the middle of the night, being on call and troubleshooting things. That's not for everybody. Some people love it, but it's definitely something that you need to be okay with. Cool. So where do you start becoming an SRE? So I'll give a little bit of a disclaimer that this industry is vast and it's constantly growing, and it seems that new exciting technologies are being released every day that generate a lot of hype and everybody gets talking about on the internet. And it's easy to be distracted by a lot of those new things that are always coming out. And there's so many of them, you could spend all day just reading and trying to learn the entire industry. So I think if you're trying to get involved in SRE and get started in this career, it's important to create a focused plan for what you need to learn ahead of time. And to that point, I'll say that the fundamentals are always going to be more important to nail down than any one awesome new piece of software. So if the internet is talking about Docker and containerization of the application is the new thing, and you're like, well, okay, I need to learn that and get started on it. It might be the right thing to do if you have a lot of the other background experience to be able to understand this new thing that's coming out. But it also might not be the right time if you're really early on in becoming an SRE. So it's important to stay focused and kind of stick to a plan to learn the basics and the fundamentals and get your feet on the ground, a really good understanding of the technology landscape before you move on to learning some of the new exciting things that are out there. So that's kind of like a disclaimer I think it's important to keep track of as you're moving on to learn. Okay, so first and the most important thing to do is to tinker around with tools of the trade. By that I mean install Linux on your computer, try using the terminal, and learn ways to configure the system. Try creating a simple Python program to solve a task that you find interesting. And that task, it needs to be specific. If you're just kind of learning code and you're just writing how to sort some list, that might not be useful without any context of what it would be used. So pick something that you find interesting and set it as a goal to build a little product, and then learn your way by building that thing. So I put an example there, a simple command line program to enter daily expenses and show monthly spending by category. It's a pretty easy program that you could build, and you might not know anything at the start, but as you learn Python, or Python I use as an example because it's a good programming language to get started with. That would be a good place to go because it allows you to direct your education as you learn things into something practical and useful that you can see how things are used in the real world. So that's kind of a recommendation that I make. And lastly, and this is the most useful way to learn, especially for SRE, is to try to break things on your computer and then fix them. So an example, what happens if you change your IP address to something random? That's always a good way to learn. So if you had Linux installed on a cheap computer and you're just tinkering around with it and you learn how to configure it and get it all set up, try breaking some stuff. Try figuring out how you can max out the CPU and have the computer not run anything. So breaking things on purpose and then trying to figure it out is always a good way to learn. So besides tinkering and playing around on your own, courses and reading tutorials are also the best way to learn. So Coursera for the win here. There's a lot of great courses here, which I'll link to at the end, and kind of provide some examples for Coursera courses and tutorials that you can read to get started. But there's a lot of good fundamental technology that you should understand in the beginning. And so some of those are, to start, computer hardware. So computer hardware is probably the most fundamental understanding that an SRE would need to have. And that's how a CPU works, what memory is, and the caches in between memory. A hard disk, how that stores data, how data is read from it. Network cards, so when network traffic comes into the computer, it goes to a network card, and how that interacts with the entire computer system. So that's kind of the first fundamental place that I think somebody should learn before diving into anything else. Get a good groundwork for what all the components in a computer are, how they work together, and lay that framework before adding on to it. Next, that I think is most important is networking basics. Now, you don't need to go full to become a network engineer and get a CCNA or some degree in it, but the basics of TCP/IP, how that communication works, different routing protocols, those are good fundamentals to have. And networking always comes up in the line of work of an SRE because it's so critical to our work. So understanding how computers are communicating with one another is really fundamental. There's an interview question that a lot of people like to ask for SREs or DevOps or systems engineers, where they'll say, if you're at a computer and you type www.google.com into your browser and you hit enter, describe everything that happens next. That's like a typical interview question. I've been asked it several times. And that's primarily a networking question. Yeah. And so there's a lot of technology that happens to get google.com loaded into your browser and have you using it. And you should have a fundamental understanding about how that works. Again, I'll link to some classes and some resources to get started in learning this, but that's kind of an overview of something that's really important. The next is programming. So SRE is not a traditional operations role where you just fix problems and troubleshoot things. There's a lot of code involved in SRE work. So it's important to take classes and tutorials and understand software, how code gets executed, how it interacts with the hardware, what code is, the difference between different programming languages, data structures and data types, what those are. And I put, another example here, Python for beginners, I think is a perfect place to start because Python is a relatively straightforward language. It's easy to read and understand. And if you had a good understanding of Python, it would allow you to then move on to different languages and different programming concepts and boost those skills. But that's a great place to start. And it also allows you to, like I said, learning, if you take classes, you always need to apply it to something in the real world that you use in order to really absorb the information. And Python is great because it would allow you to build something simple, like that finance app that I said would be a good place to start. You could build that relatively simply in Python. If you were doing it in C or C++, it would be a lot more difficult. So Python is a good place to start. Next is troubleshooting and debugging. So this is troubleshooting and debugging problems that would occur in a computing environment, so with software or hardware. So there's a lot of classes out there for how to troubleshoot computers, how to troubleshoot networks, how to troubleshoot a software bug, how to profile software. And there's different tools that you can use to troubleshoot all sorts of these issues. And those are really, really important skills to have and fundamental to what SRE does. So that's something that should definitely be learned kind of as a basic understanding before you kind of get moving into your SRE career. And again, what I said before, if you have Linux installed on a cheap computer at home, if you try breaking things and then fixing them, that's a perfect way to learn. And so if you break things and then use the tools that you've learned to diagnose and fix problems, it'll get absorbed a lot easier as you take the classes. So that's a really good way to go about things. And so I put together this little kind of, this skipped a few slides. Next is databases. Databases come in a lot of forms and varieties, and there's a lot of different types, but essentially almost all software systems need to store data. And databases are critical to all of these engineering organizations. They all use a slew of different types. I put two examples there, MySQL and Cassandra. I could have picked any of the dozens of types of databases that are used, but those are two common ones, so I picked them. And understanding databases is, from a high-level overview, is really important because they're used so much in the software. So understanding kind of what the goal of a database is, how they store data, how they communicate with one another, how the software would communicate with the database, how it would store data and read data. That's pretty important in the SRE skill set. So I would definitely recommend learning and reading about databases and kind of getting started with those fundamentals. Let's see here. Okay, so next is distributed systems. So distributed systems is kind of how everything in this modern technology world works. So a company like Google or Facebook or Netflix, an application there couldn't run on one server. You can't have all of Netflix running on just one computer. they have thousands and thousands. And in order for that to work, you have an application that needs to work across thousands sometimes, or dozens, or even two different computers. There's a lot of concepts in how that has to happen. Some of them are load balancing, data replication. Those are just two examples of different concepts that are involved when you want to get something working on across a lot of computers. And as an organization grows, so if you have a website and it's a website where people are buying something, let's say, if more and more users start using your website, the servers that are running that code are either need to get more powerful, or you need a lot more of them. And there's a limit to how powerful a computer can get. So the only answer is to add more and more computers. So, and that's a very challenging problem. So distributed systems is kind of the educational landscape for how people get an application running across a lot of different servers. So those skills are really important to understand. They're vague, and a lot of times the distributed systems work is learned only once you really get into a company and start getting your hands on, because it's hard to build some really scalable application on your laptop and test out a lot of these theories. So it's a little bit of a hands-on approach once you get into SRE. So okay, so I added this little word cloud here for some terms that I pulled from the internet that are really common in SRE conversations. Linux was the biggest one. Ansible, which is a configuration management service. Nagios, which is a monitoring tool. Python is just probably one of the most popular programming languages. Puppet is kind of like Ansible for configuring systems. So it's interesting just to see where the conversation is going. What tools are people talking about? So my computer is having a tough time. Okay. So another thing that's important to do is to get involved in the conversation. The number one way is to follow engineering blogs and forums. So I put two there that I read that I think are really interesting, and that's Julia Evans. She has a great website. It's updated a lot with different ideas and learnings. So that's a great one. And also Brandon Gregg is a great engineer, writes a lot about Linux and networking and troubleshooting. So those are two great blogs to get started with. And once you read those, you can start branching out to other things that you find interesting. Another is a good site, sreweekly.com. There's a lot of posts and conversation happening on there. So reading blogs and forums is always good to keep up with how the industry is changing and what's happening. So sometimes it's overwhelming. So it's easy to get distracted and feel overwhelmed that you're now exposed to all these things that you don't know. But it's also sometimes cool to just get tidbits here and there of, okay, here's this thing that came out and I know it's there, and if I need to, if I'm interested in it, I can get involved and learn a little bit more. But if not, at least I know that it exists. So that's always good. And it's always good to learn about best practices and different things that other people are doing. Another one is to ask questions on Stack Overflow. So yeah, that's an example of a place. There's tons of other forums and places to ask questions if you run into problems. But you usually get a lot of community answers and help when you post questions and show interest into figuring something out. And lastly, find some of the projects that you're interested in and keep up with them and how they're changing. So I put an example here for me. I love Go, the programming language. So I get the newsletter and I follow the changes pretty regularly. So when a new version of Go gets released, I look through the release notes and see, here's these changes that they made. And then sometimes I'll tinker around to see how I can use these new things that come out or new tools within Go. So sometimes you might be interested in a database or Linux itself or some networking technology or virtualization technology. There's OpenStack and a lot of these other tools that are being used. And if some of them excite you, definitely stick to the conversation about that tool and how it's changing. That'll always be really helpful. So there's always some places to start, like great Coursera courses. And I put some here that I've taken some of these, and if not, I've definitely thought about it. So these are a great overview of some of the tools and ideas that we talked about here. The first is Operating Systems and You Becoming a Power User by Google. That's a great course, an introduction into what an operating system is and how to interact with it, what it does. Cisco has a great course in networking called Data Communications and Network Services, and that can serve as a good high-level overview of networking and how it works and the things that it accomplishes. The University of Michigan has a specialization called Python for Everybody. It's a specialization, so there's a lot of courses in it. But it's a great place to get started in Python programming, and it'll give you an overview, but it also goes pretty in depth to some of the concepts in Python. And like I said, if you're taking a class in Python or a programming language, I really recommend having a little project in your personal life that you plan on building, so that you can, as you learn something, you learn how to sort a list of numbers, you can apply it to something real that you're using and building, and then that'll make that information stick a lot more. So that's definitely something that I recommend. Google also has a course called Technical Support Fundamentals. So that's kind of one of the basics for what SRE is troubleshooting, diagnosing problems, fixing them. And so that's a great course to get started with. And lastly, the University of London has an Introduction to Computer Science and Programming. And like I said earlier, the most important aspect to getting started in SRE is to really understand the fundamentals. Like we talked about, computer hardware, code, and programming, how software gets executed. And a lot of that is learned in an Intro to Computer Science class. So I would really recommend people take, maybe even before you start programming with Python, take an Intro to Computer Science class and learn kind of the basic ideas of what's happening here. What is a computer doing when you execute code? So that's a good place to get started. And I'll post links in the forum after this webinar so people can kind of click and dig in to learn a little bit more. So yeah, again, I'll reiterate, always get hands-on with the experience that you learn in a course. Otherwise, it'll be very difficult to remember. So I can't stress this enough. If you're taking a course in Linux and learning how Linux works, if you have a cheap computer that you can install Linux on, that can go a very long way in learning, because then you can just tinker with it, you can experiment, you can play, get your hands on into the different things that you're learning. Super useful. Lastly, if you're interested in a programming language or database, come up with a project and build it using that database or that programming language. That's how you learn things. So definitely always accompany a course that you take on Coursera or anywhere else with something that you're doing in the real world, be it at your job, or if you don't have a job in this industry yet, something on your computer that you can do easily at home. So why is SRE a good career? Why am I advertising this? Well, it's a rapidly growing field with a lot of job opportunities, and it's expanding more and more into different industries and different companies. They're all realizing that this is a great way to do things because it's a software automated approach to a lot of these things that we had been doing with traditional operations roles. So it's growing, and getting into an industry that is growing and expanding is always a good idea because there's a lot of job opportunities, there's a lot of educational resources and conversation, and it can lead to a lot of good things. The next I'll say is SRE is really central to the success of any engineering organization. So it's always really highly valued. So companies like Dropbox or Google or Uber, they have SREs, and they realize that this is how our application has really good performance and is really reliable. We need to have Uber up and running 24/7. It can't have any problems. So we need to invest in SRE to make that the case. So being in an organization that is really valued is always a good place to be, because your work is viewed as being very positive and helpful to the company. So lastly, it's a broad field with many areas of expertise to find interesting, and that leads to a lot of career growth within the organization. Again, all helpful stuff. And I'll mention that it's challenging. It's not an easy job. You come in and you're faced with a lot of difficult problems, and you have to learn a lot of challenging things that you may have never seen before. And boring work wouldn't be fun. So that challenge is pretty exciting to keep people interested. And that's one of the things I like most about SRE. So I'm going to go back here because it missed a slide for how I got into this career. So for me personally, since childhood, I loved computers and learning how they work. I remember being a kid and I had no idea how anything, when I was young, didn't know how a computer worked. And I would be editing Windows registry key values and just messing up my entire computer just because I didn't know what it was. And I was like, well, how does this work? So I always loved computers. So then I went in to study computer engineering. And during my computer engineering degree, I got an internship as a network engineer. And I found it interesting. It was a fun job. So then when I went on full time, I got a job as a Unix systems administrator. And I worked in that kind of field for a few years. And then I moved into more systems engineering, and I was working with OpenStack and a lot of automation, and I was doing Python scripting and programming work. And so that was kind of expanding the things that I learned about. And that's where I started to get really excited about this industry. So I was at the time writing a lot more software, and I was doing a lot in C and C++ and Python and learning Go. And so eventually I switched into a full-time software engineering role. So I spent a lot of time just writing code, and that was pretty exciting. So after working in the software engineering for a little while, I realized that SRE is pretty perfect for me because it combines the best of both worlds. I can write code and interact with the software engineers, but I also still get to be involved with the infrastructure, with Linux, with the hardware and the distributed systems work that I really find interesting. So that was, a perfect evolution for me to go from networking and systems to software to then SRE. And SRE is kind of the final place where I tied everything together. So that's kind of how I got here. And in my typical day, I think it's cool for someone to see what does an SRE day look like. So I mentioned I work at Dropbox now, and so in a typical day, I'll be debugging systems, and it's not a ton of problems in one day. A lot of times it's one problem that will take me a lot of time to figure out. So that's kind of it's an interesting part of the job, and I'm looking for clues, and some of the tools I'm using are perf and strace and TCP dub. I look at graphs and time series and log messages. So that's kind of like debugging is pretty central to what I do. I also write a lot of software. I use mostly Go and Python these days. And a lot of the software that I write is to add or fix monitoring code to kind of understand our software and what it's doing. I write software for performance improvements and bug fixes, or to clean things up and make our code base look like it should. Get rid of code that's not being used or that has bugs in it, make things more readable. So that's a big part of my job. Maybe 50% of it is writing software. And then I contribute to design discussions. So if we're building a new system, there's a lot of different things that need to be thought of, like how is it going to scale in a certain way? How is it going to address these problems? So SRE always has a very active voice in those design discussions, and I'm always at the table and really interacting with the design of any new systems that we're building. And periodic on-call rotations. So part of my job is that every few weeks I'll have a week on call where I'll be responsible for a lot of issues that come up within the Dropbox infrastructure that I work on. So that on call is it can be an exciting part of the job where you get to see different parts of the infrastructure and troubleshoot some interesting problems. And that's definitely a real part of the job, of the day-to-day. So with that, I will turn it over to any questions, or if Laura has anything that that she wants to say.
Thank you. That was wonderful. As someone who is not savvy on this topic, I found it interesting and understandable. I think a lot of times I feel like it's maybe over my head, but I feel like I learned a lot. So thank you.
You're welcome.
I did have one question that I'm curious about, and that is whether you have a sense of whether or not your career trajectory is similar to most SREs. Like, do you feel like people end up as SREs in all different ways, or do people tend to follow a similar path in terms of other jobs they've had before they get to that point?
Yeah, that's a great question. And I'm glad you asked it, because it highlights how somebody who's not working even in technology could get into SRE. And I've seen this a lot of times. I was probably throughout, from the past up until the past 5 years ago, the way I got into SRE was probably the most typical way. People who had systems experience and then learned a lot of software. And then as SRE became a thing in these organizations, they just moved into it. But now, since SRE is pretty big and it's in all of these companies, you see a lot of people coming from hack boot camps or code academies where they take a 3 or 6 month boot camp, and then they're looking for jobs and they see, oh, well, that infrastructure SRE work is pretty exciting, and they learn the skills and then they get into it. And I was actually talking to somebody at Dropbox who went through that path. They were working in another industry. They took a code boot camp and then found it interesting and then moved into SRE from there because it was an exciting field that they found interesting. So you're seeing that a lot more and more, that people are just kind of learning the skills necessary and taking SRE as one of their first jobs as an entry-level SRE position. And part of the reason is because it's so easy to learn a lot of the tools and skills that an SRE needs. And the Coursera courses that I talked about are probably a perfect example of that. You could take all of those courses, and then from there, you're going to learn, oh, they talked about this one thing in that course, and I didn't really understand it or know it. So I'll find this other course or this other book about that. And it's so easy to get all this information now with places like Coursera and books online that are really easy to get, that you can learn all of these skills in less than a year and get an entry-level position and then grow from there. So now it's probably a huge mix of how people get into SRE, from my trajectory to people who go through a boot camp or just taking courses and then switching into it. Or the last is people who have just been a software engineer for a long time and want to get more low-level infrastructure work, so they switch into SRE. So now it's a big mix.
Great, thank you.
Yep.
So I think that's all the questions for now, but we look forward to seeing you in our community, in the Coursera community. And I know you said you would be sharing the links to those courses and the specialization that you mentioned. And if you are watching this and you have more questions about being an SRE, please do ask your questions here in the Coursera community. And hopefully we can connect you to some other community members who are interested in the same topic, who have experience, and who can give you some guidance. So want to just thank everybody for attending, and thank you, Henri, for presenting today. We really appreciated it.
Yeah, no problem. Thanks.
Okay, see you later.
Bye.